tools available. For my demonstration, what I'm going to do is I've already registered myself on the github.com by providing my username and my password. And I'm going to use a free account. So whatever repositories that I'm going to put up on this server is all public by default. So I've already registered myself by using my username or my email ID and my password. So this set of authentication is also referred to as HTTPS authentication. So in order for me to share my repository with say user2, the first thing that I got to do is have an access to a Git server where both user1 and user2 are set up. So once I have that, I can push my repository onto this server and provide right kind of access so that user 2 or the other developer who wishes to collaborate with me on this repository can use his credentials. As long as he's registered properly on the Git server, he can use his credentials and pull down this repository and work with this repository. So this is the HTTPS way of authenticating and sharing repositories. Another popular way of sharing repositories or working with each other is called as SSH authentication. As many of you would know, SSH means nothing but creation of a private and a public key. A bunch of keys, public and private, are created on the client machine. While I create keys, I will be asked for a passphrase. I need to type in a passphrase and remember my passphrase. And then I take this public key and kind of post it onto my account within my Git server, so that whenever I'm going to connect next time using my command prompt or any of the tools, it's going to challenge me for my passphrase. As long as I remember my passphrase correctly, I can authenticate myself and get into the server. So both HTTPS and SSH are popular ways of communicating with the Git server. Having said this, let me just get started by installing the Git bash on my local system and then fire up some of these Git commands and build up some repositories, make some changes in my repository, commit these changes, and later use my GitHub credential to connect to my GitHub server and push my repositories out there. Let me now go ahead and find my Git bash for my Windows so that I can go ahead and install it. So I just type in Git client for Windows, open up a browser and type in for this. The first one that I find is a GUI tool. I don't need this GUI client, I need this one. So this is the Git client or the Git bash that I was referring to. It's about 40 megs, and let me just download this. Pause this video for some time so that the download happens and come back to you once I have the download. The download seems to be complete. When I'm recording this video, the version that I have, the latest version that is there is 2.19.0, and this is a 64-bit version for Windows. So I've got that downloaded. Let me go ahead and find it and install this exe. All right, I go ahead choosing all the default options. I want it to be installed in program files under the Git folder. Everything looks good for me. I'm not going to make any changes here. Git bash from Windows. Yes, I may want to use Git from Windows command prompt. That sounds good for me. OpenSSH, that's fine. Looks good. Looks good. No, I don't want any of these new features. So what I'm doing is installing the Git bash or the Git client so that I can start using my Git commands. And the version that I'm using is 2.19.0, which as I record this video, this happens to be the latest version. All right, so looks good. I don't want to see the release notes. I'll say launch Git bash. So what I get is this window. So this is the Git command prompt. So let me check if everything is looking good. Say Git version, it sounds good. Say Git help. All right, a lot of Git help commands. Everything looks good. So I ended up installing the Git bash. I can go ahead with all other commands. Now that I have Git bash installed on my system, let me open up a Git bash prompt and start using it. But before I do anything, I just need to configure it for the first time, stating what would be the username and the email ID with which I want the Git bash to be configured with. The command to do that is git config --global, which means that this setting that I'm going to set would be a global setting. User.name, and this, the name of the user would need to be specified within a double quote. In my case, I am using a simplilearn account, which is the official account, and this is the particular username of this account. The other setting is nothing but git config -f global. This is also a global setting. And this would be the email ID. The email ID need not contain a double quote. So in my case, this is the email ID that I would be setting up Git to work with. All right, let me check if the configurations were set correctly or not. All right, if you see this, the username and the email ID has been picked up the way I wanted it to be picked up. Looks good so far. All right, so what do we do next? By default, whenever you open up the Git prompt, you're placed into your home directory. Let me create a folder here, which would be a repository folder from where I'm going to create all my multiple Git repositories. So I will create a folder called, let's say, git_demo. All right, there's already a folder called git demo. So let me just delete that in the first place and let me create this git demo again. All right, let me navigate to this particular folder. So this is the folder. Let me open up that folder using a command prompt. This is my git demo. So this would be a folder. So I would use this folder as a base folder for creating all other repositories as a part of this demo. So let me create my first repository. A repository is nothing but a folder. So let me create my first folder called first repo. And let me get into this repo. All right, as of now, this is just an empty folder. If at all I navigate to this, you would see that this folder is empty. There's nothing much in this folder at all at this moment. Okay, so let me create a repository out of this. How do I create a repository of this? It's pretty simple. I just run a git init command. When I say git init, it means it's going to initialize a repository. As of now, the folder contained nothing in it. It was an empty repository. So it initializes an empty repository in this particular folder. If at all I look at my content, you would see that there's a hidden folder. This would be a hidden folder since I've configured my Explorer to view all hidden folders. I see it, otherwise you wouldn't see it. So a folder by name .git is created within this first repo. And this was created because we ran the command git init. If I get into this folder, I see a bunch of directories and other configurations. If you see, there's something called as a hooks directory, a couple of configuration files that are here in this directory. All these relate to one or the other type of a client hook that can be enabled. And there's info, there's objects, there's references, a bunch of stuff that is there. So what is this folder? This is a magical Git folder, and this is created whenever a repository is initialized. So by default, if at all you get into any Git folder or any Git repository, you would see this .git folder. A word of caution, do not get into this folder and try to modify anything, because if you fiddle around with this and corrupt this particular folder, your whole repository will go for a toss. So let me come out of this and let me show you another thing. Now, if you notice here, when I was in the folder, the repository did not have anything after this. Now, when I say git init, there is something called as a master that shows up. So typically what happens is whenever a Git repository is created for the first time, it creates a default branch. The name of the branch is called master. And that is why you would see master within braces. This doesn't mean anything else other than we have a repository out in this particular folder. And by default, there is a branch called master and we are currently on that branch. If at all I create multiple branches in this folder, whenever I navigate to different branches, the branch name within these brackets would change. All right, so far so good. So we created a folder, we made it a Git repository by initializing that with a git init, and then I've not put anything yet in the repository. So let me try to do that. Let me create a few files within this particular repository. So I use a touch command. Touch is a Linux command. It kind of creates this particular folder. If at all you're not comfortable with the file creation by this way, you can always use a file explorer and create some files in this. So I create a file called touchmaster.txt. I'll open up in the notepad. Okay, so this is my first file. That's what I'm going to write inside this. I save this and I come out of this. All right, now let me do a git status command. So what does this tell you? There's no commit set, you're on the master branch, there is an untracked file, and this shows up in red. It also gives you all the commands that is supposed to be run. So if at all you want to add this file, you would say git add and the name of the file, and then you're going to commit it. So what happened is that when the repository was initialized, it was an empty repository. Now that a git notices that there is a new file in this repository called master.txt. If at all you want us to let git know that you want to track this file, we need to add this to the repository. So the command to add that is called git add. I can specify either the name of the file or I can give a wild character saying git add dot. Now if I run the git status command again, it says there's no commits yet. Added a file, and the file which was earlier in red now shows up in green, and it says it's a new file, master.txt. All right, it also gives you something called git remove command if at all you want to unstage or undo your changes. So what has happened is the file which was earlier untracked is been added into the git index, or it is ready for staging, or it's in a staged state. Now I can go ahead and commit this file if at all that's what I want to do. So let me do that. I'll do a git commit -m and I give a message that I want. I would say this is my first git commit. All right, I run the git status command again and see it says on the branch master, nothing to commit. It's all nice and clean. So typically what happened was I created an empty directory, made it into a git folder by doing a git init. I put a file into it. I made some changes to the file. I added that file into the repository and I committed to the repository. If at all I run the git log command, it says this was the commit ID or the commit number or the commit hashtag, and this is the author. If you notice, this is the email ID and the username that we set earlier. This was done on this date, and this is the commit message that is there. All of it looks so good. Let me do one more commit into this repository. So I will touch master1.txt. I'll put in another file. I'll open up this particular file, write something into this. All right, I save this change. Let me also open up the older file, make some more change into this. All right, so what I did, I modified the older file that existed. I also added a new file to my repository. Now, if I run the git status command, it says modified this file, which is showing in red, and it says you have one more file, which is an untracked file. All right, now let me add both these files because these are the changes that I want to incorporate. I would say git add dot. I run the git status command again, and it says now this is a modified file, this is a new file. Looks good to me. Let me go ahead and commit this. So git commit with a message that says this is my second commit. All right, if I do a git log now, it shows both the commits. The first commit is the one that shows up at the bottom, and the topmost one is the latest commit that is there. So far, so good. If at all you notice, I'm doing all these git commands without really connecting it to any git server. I don't need any network connection for doing any of these things. I can keep on doing more and more git commands and run git commands the way I want to without really having any connections to the git server. Now that I have my changes the way I wanted, and I've checked in all the code changes into my local repository, I may want to share my repository with somebody else and work in a collaborative way. So the way to do that is, as I mentioned earlier, to host this repository or to push this repository onto a Git server. I already have a GitHub account wherein I've registered myself using my username and password. So I log into my GitHub account using my username and credentials, and let me go ahead and create a new repository. My repository is already there on the local system, so what I essentially need is just a placeholder for my repository so that I can link them together and push the content from my local repository to the server. If you notice, the name of my repository is this first repo. So let me copy this. I would create a folder structure or a repository structure on the server with the same name so that when I pushed my repository from my local box, it will go ahead and get created in the server. So the repository name should be the same as what I created on my local box. Description, I would say this is my first GitHub repository on the server. This is just an optional description that will show up. And if you notice, I can't have any private repositories. So whatever repositories that I'm going to create here would be a public repository. So I choose public, and I don't want to initialize this with a README file or anything of that, because I already have a repository with some content with some code checked in. All that I need is a placeholder for my repository on the server. So with this option, with just the name and with an optional description and the repository being public, I go ahead and click on the create repository button. So if you notice, it gives me a bunch of commands that I would need to run in order to create a repository and push it onto the server. And also, important point, it shows me two URLs. One is the HTTPS URL and the other one is the SSH URL. As of now, we do not have any SSH keys that is set up. So let me use this HTTPS URL to connect my local repository with the repository on the server. So I've done all these things. I already have the repository set up. All that I need is a placeholder for me to connect my local repository with the server URL. So this would be the command that I need to copy, which essentially links or adds an origin with the URL of the Git server. I just copy this command and run it here. Git remote add. The name of the remote is called origin, and it points to an HTTPS URL, which is nothing but the placeholder that I've created on the server. All right, so let me check if it's added correctly. Okay, the URL looks good. I'm all set. I've got 2 commits in my repository. I'm done with all the changes. So let me try to push my repository onto the server. The command for doing it for the first time is git push -u. This is for linking the upstream origin master. So git push -u upstream linking origin master, link the master branch of my local repository with the master branch on the server repository. And where is it going to push? It is going to push by default to an origin, and the origin points to this URL. All right, let me try doing this. So it essentially opens up an URL asking me the credentials with which I need to log into my GitHub server. So let me just copy and paste the username and the password with which I've registered. I would say login. Okay, success. So I'm able to create a repository on the server, and the content seems to be pushed, and it created a new branch called master. It has linked the master branch from the local repository with the master branch on the server. So let me go back to my server and refresh this page and see if all my commits have come in. master1.txt. If at all I see the commits, there seem to be 2 commits. This is my first commit, this is my second commit. And if at all you notice, each of this commit comes with a hash key or a hash ID, which contains the details of my commits. In this commit, the files were added. This was the line that was added. If you look at the second commit, I added these lines. I made this, 1 line chain that was there. I also added this new file which was not existing. These are the 2 commits that existed. And if you see the timestamp of the commit, this is the commit which was committed 15 minutes ago. So what does this mean is that the commit is the timestamp when we actually committed the code in the client. The pushing is just after we have committed the change, we have pushed it. So there's no timestamp of the push that happened. This completes the first part of the tutorial, wherein I created a repository on the client and then I pushed it to the server after creating a repository skeleton on the server. Now let me demonstrate to you the SSH configuration that is required for creating a pair of SSH keys and ensuring that I connect to the GitHub server using the SSH mechanism. So for doing that, I need to first create a pair of private and public key. The command to do that is ssh keygen -t. I will use the RSA mechanism for creating my keys, capital C, and I need to specify the email ID using which I'm going to connect to, or I need to create the keys for. Alright, so generating a private and public key pair, it says, let me know what folder should I create the keys in. So by default, the keys are created in the user home directory under a .ssh folder. So this is pretty good for me. So let me go ahead and say that, that's fine. Enter a passphrase. So let me enter some passphrase. Keep in mind that I would need to remember my passphrase because when I'm going to authenticate myself using SSH mechanism, it will challenge me for this particular passphrase. I need to enter the right passphrase so that I get authenticated. So the key is generated and by default it is created in this particular folder. So let me go over to that particular folder. And this is the folder where the keys is generated. You would see a public key and a private key that is created. Let me open up the public key with a notepad and then copy the contents of the whole file. And now I would need to stick it in on the server so that I can get myself authenticated using SSH keys. So I've logged in to GitHub using my credentials and go to my settings. And you would see an SSH and GPG keys. Let me click on that. As of now, there are no SSH key or GPG keys. So I will click on new SSH key and let me paste my public key that I've copied. And I would say add SSH key. It prompts me for my password just to make sure that I've got the right kind of authentication to be adding a new key. So this one looks good. That means the keys were added successfully. Let me check if my SSH keys are working well. So I do SSH -T. I would say git at github.com. This is just to double check if my SSH keys are authenticated correctly. Are you sure you want a connection? Yes. You want to continue? Yes. All right. Now a check for my passphrase. Let me enter my passphrase. I hope I remember it correctly. All right. Pretty good. I've been successfully authenticated. So that means now my SSH keys are good. And just by using my passphrase, I can connect to my GitHub server using SSH. All right. So for the second use case, what I would do is create a repository on the server with some content in it and then clone that repository. Cloning is nothing but making a copy of that repository, linking the origin so that I create an exact replica of the repository which is there on the server on my local drive. So let me first create a repository on the server. I will create a new repository. Let me give a name for my repository and let me kind of initialize that with the README file. I would call this my second repo. Give some description. This is my second repo that is created straight on the Git server, on the GitHub server to be precise. It's a public repository. This time I'm going to choose this option. The reason being that I don't want to create just a skeleton as of now. I want to create a repository with some README file in it. A random README file with no content in it, but then I want a repository to be created on the server. All right, I say create a repository. So a random README file with some content in it gets created and I can see there are two URLs to this repository, HTTPS and SSH. So this time, let me copy the SSH URL so that I will use this URL to clone this repository on the server, rather from the server to my local box. All right, so let me navigate to my root folder, the folder that I created for making all my repositories, Git repositories. If you see, my first repository is already here. So let me clone my repository, the second repo that I created on the server. The command to do that is git clone the URL of the repository that I want to clone. Oops, looks like I didn't copy the URL correctly. Let me copy that again. Copy this URL. All right. So if you notice, there is no HTTPS to it. I'm just cloning the URL, that is SSH URL of the repository. It asks for my passphrase again. Okay, so I just had first repository earlier. Now I have something called a second repo. This is an exact replica of whatever was the repository content that was created on the server. So if I get into the repository, there's just a simple readme file that is there. Let me try to add a new file out here. I would say notepad, second.txt, some text file I'm going to put in here. Yes, definitely you will not find that file there. This is my second file that I will push onto the server. I'm going to put in some content out there. I'm going to save this. And if I do git status, it says this is a new untracked file. Do you want to add this file onto the repository? Do you want to track this file? Yes, I definitely want to track this file. Let me also commit my change to the file with a message. This is my first commit for the second repo. I give in some particular message. And this time around, since I cloned my repository from a server, the origin is already set for me. I don't really need to add the origin and all that stuff, because what happened in the first case was that I was creating a repository from my local box and then pushing it on the server, which is why I had to set up the upstream branches and stuff like that. In this case, I have cloned an existing repository from the server. So when I clone, I get the replica along with all references to my repository. So I don't need to do anything more other than push the content. I would just say git push. To be on the safer side, I would say origin and master. Ask me for the passphrase. Okay, it pushed the content onto the server. Let me see if the contents have come in here. Okay, wonderful. I had only one commit. Now I see my second commit. So what was added as a part of the second commit? It says a new file was added. All this line that never existed got added. This is the second file, the content exactly what I pushed onto the server. Now this completes the tutorial when I created a repository on the server, cloned it, made some changes to the repository and pushed it to the server using SSH. A quick recap of all the git commands that we ran till now. Git init is used to initialize a repository. So if at all you're creating a local repository, you can get into any of the folder which is not a git repository and run this command. Whenever you run this command, a magical folder by name .git gets created in the folder, and from that time onwards, Git will start tracking any changes that happen to that particular folder. It also creates a new repository and a branch. By default, the branch that is created is called the master branch. Git add dot is a wildcard character for adding any number of new files into your Git repository. If you have a bunch of files, 1 file, 2 file, 10 files, a folder containing multiple files in it, all of them could be added into the repository using this command. So once you add any number of files into the repository, you can keep on adding more and more files into the repository. Once you're done with that, you want to commit the changes that has happened in the repository, you use the git commit command. Git commit -m with a meaningful message. This will commit all the work items that you've done in terms of the files that got changed, the files that got added, all this with one particular message. Git status will give you the status of all the files and folders, any file that got added, any file that got created, any file that was deleted, all the status of the files will be obtained using the git status command. Git log will show you all the commit history with the latest history or the latest commit showing up on top. Git add remote origin. This command is used whenever you want to link any local repository to a server. And this is when you want to really push a repository from the local to the server for the first time. Git push -u origin and master. This is the command that you would use whenever you want to push contents from the local repository to the server. Git clone and the URL of the server. This is the command that you would run whenever you have an existing repository on the server and you want to make a fresh clone or a fresh copy of that particular repository onto your local box. More than often, Many developers or Git users find themselves in situations where they would want to go back in history and modify or change some of the files that they recently committed or checked into the repository. Now, from a perspective of Git, this is a very simple activity. However, from a perspective of version control tool, you will have to be really cautious about the change that you're going to do. In case the changes are pretty local, none of the developers or none of the other users who are collaborating with you would be affected by this change. You're good to go ahead and make this change. However, if your repository is being pushed to the server and you're trying to modify something from history, this would have a very bad or adverse effect on all the other users who will be using it. You need to be really cautious while running these commands. In case your repository contents are local, you've not pushed your changes to your repository, and if at all you made some changes to the repository, maybe to fix a defect or to include a new feature, and you missed few things, you can go ahead and modify this with some of these commands. Let's say I have this simple repository called undo repo, and if at all I look at the logs of these, I have the commit histories which are like this. I have about 5 commits that is there in my repository, and in C1 I've added a file, in C2 I've added another file, in C3 I've also added some file, in C4 I've made some changes to M1 and M3, and in C5 I've added another file called M4. Now this is my commit history. Now let's say I made these 2 commits, but possibly I want to club them together along with some other changes because whatever changes I did not really fix things the way I expected it to fix. So there is a git command called git reset. This would allow me to go back in history, to go back to any of the snapshot, get rid of all this commit history or the commit messages, but retain the changes that were made as a part of these commits. So if at all I need to go back in history and go back to this particular commit, and however, I just want to get rid of these commits that are there in terms of the commit messages, but I want the changes that were there as a part of these commits to still exist. I would do command called git reset -- soft. Now this would go back or unwind my changes back to this particular snapshot, getting rid of all the commit messages that were there as a part of these 2 commits. But a soft would ensure that the file changes that were done as a part of these 2 commits would still exist or would remain. So the command for that is git reset -- soft, which is the snapshot that I want to get back to. If this is the commit that I want to get back to, I just copy this and I paste this. All right, it doesn't give me any message, but if at all I do a git log pretty one line, what it says is C1, C2, now the head, which is nothing but the current pointer, which was earlier pointing to C5, it's gone back to C3. Now what happened to the changes that were there as a part of C4 and C5? If at all you do a git status, if you see the changes that were a part of C4 was some changes to M1 and M2, and C5, a new file got M4 got added. If at all I do a git status, you would see those changes still exist. However, from the git history or the git commit history, C3 is the topmost commit that exists as of now. C4 and C5 have been gotten rid of, but the changes that were there still exist. All right, now I can make some more changes that I want if as a part of my commit and possibly go ahead and commit this whole thing as a new commit altogether. Maybe I'll open up a notepad and possibly create a new file called m6.txt and say one new file that was missed out. I make this change. I go to a git status. All these files are still there. I would say git add dot. I would say git commit -m C4 rewriting history, and I do a git log pretty. There you go. So C1, C2, C3 still existed, and whatever was a part of C4 and C5, the older ones, I've gotten rid of this. Along with those old changes, I also added a new file. I made some changes and I was able to commit it. Now if you look at my git history, it's all nice and clean. However, do this activity only when you don't push your git repository to the server. One other most powerful and useful command while undoing or resetting the history is something called as revert. This is a safe way of undoing some things. Remember what I talked about when exactly you can do a reset? It's only when your changes are local and is not being pushed to the repository. Take this scenario wherein, let's say I have a Git server and I have the changes which are C1, C2, C3, and possibly C4. All right. So this is a bunch of commits that has happened. This was the oldest commit and this is the newest commit. And if at all developer one is the one who's responsible for pushing these contents in the first place. So he has got C1 to C4 on his history. I'm going to jump all these C2 and C3 and get into C4, and he's pushed all these contents out here. And there are a bunch of people from the server who has pulled this repository, and all of them are at the same level. Now imagine a use case where developer one then figures out that by mistake he put in the C3, which was the wrong thing to do, and possibly he could have done a better job of fixing this in a different way. So he wants to get rid of the C3 or C4 or any one of these commits. If he's going to do that and push it to the server, first of all, the Git server would not allow him to go back in history. But assuming that he forcibly pushed something, what would happen to all these people who are looking to work ahead from C4? All of them would be affected in an adverse way. So in short, never go back in history. If at all you need to undo something, go ahead and put in a new commit to undo something. Let's take this example. Maybe if at all a developer one wants to get rid of C3, better way to do that is by adding a new commit which is ahead, say let's say C5. And what does this commit do? This commit possibly gets rid of C3. Instead of going back in history, it actually is taking your Git history ahead. But as a part of this commit, you're undoing some part of the work that was done as a part of C3. In short, you're removing a commit, but to remove a commit, you're adding a new commit. And this is why you're doing it, because there are a bunch of other people who are you're using this repository collaboratively and who are planning to get ahead in terms of history. They cannot afford to go back in history and modify something in history. All right, the command to do this is called the git revert command. So let me take up this repository, which has got a bunch of commits in it. And if at all I do a git log, pretty one line, I have these bunch of commits. In C1, I've added a file. In C2, I've added another file. In C3, I've added one more file. And in C4, I made some changes. And this is the latest commit, and this is the oldest commit. So if at all I see the contents of the Git folder, it contains M1, M2, M3, and M4. And let's say, looking at the previous use case that I mentioned, I may want to get rid of this particular commit. I want to get rid of the C3, which is nothing but I've added a file called m3.txt, but I added it by mistake. I need a better way of fixing it. Possibly I'll look at it later on, but for now, I don't want this particular commit and the changes that were made as a part of that commit to exist. So the better way to do that is using the git revert command. So git revert and the commit ID, whatever I want to revert. So if I want to revert this, I copy this particular commit ID, and bear in mind that considering a reset, revert works on one commit at a time. So I can do one commit revert at a time. I can club a bunch of them together and do one commit, but otherwise the revert always works on one commit at a time. So git revert, paste this. Essentially what I'm trying to do, I'm trying to undo this particular commit. While I'm undoing this commit, what does git do? It safely adds a new commit, and a part of this new commit, it undoes whatever changes that were done as a part of this commit. So if I say git revert this, all right, I forgot to mention a message, which is why this window is showing up, but that message is good for me. I say write and quit. All right, and if I do a git log, all right, if you see this, C1 still is there in history, and our history is going ahead from C5. I see another commit, but what was there as a part of this commit actually is getting rid of this commit C3. So if at all I see my files here, There's only M1, M2 and M4. M3 was added as a part of C3. Now I've gotten rid of M3 by getting rid of the revert command for C3. So this is a better way of undoing things. Now that we have acquainted ourselves with few of those basic Git commands, let me get into a very interesting topic regarding Git, which is about branching. The topic is interesting because Git deals with branches in a completely different way compared to any other version control tool. In most of the version control tools, whenever you create a new branch, a complete copy or a subset of the whole repository is created, which in my opinion is very cost inefficient because it is a very expensive operation both in terms of time and the disk space. However, in Git, you just create a very lightweight movable pointer whenever you create a branch. There is no folder or no copy of the repository that is created. In short, the branches are very inexpensive in Git. So go ahead and create any number of branches that you need. However, once you create your branches, do all the work relating to that branch in that specific branch. And once you've completed your task, go ahead and merge your branches back into your base branch and then delete the branch. Let me go ahead and create a repository with some branches in this and give you a demonstration of that. So let me go back to my base directory, which is git demo, and then I'm going to create a new folder here. I'll create a folder called org details. Alright, this is my folder here. Alright, I navigate into this folder and let me create a repository here. I initialize a repository and .git folder is created without any files in it. So let me create a few files in it. Say notepad name.txt. Organization name. I create a name.txt within this. Maybe I'll create one more file in this. Notepad employees.txt.
सुजीत शर्मा, आपका फोन बज रहा है। 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 सुजीत शर्मा, आप सुजीत शर्मा, आपका फोन बज रहा है। 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 सुजीत शर्मा, आप सुजीत शर्मा, आपका फोन बज रहा।
I see only one commit and there are two files and you can see those two files that is here. Alright, so at this stage, let me go ahead and create a new branch. And the command for creating a new branch is get branch name of the branch. So let me name my branch as Bangalore branch, BLR branch. And this created a branch. But I don't see any changes in the folder structure or in the file that exists here. I've just created this branch. So if at all I do a git branch, I see these two branches. And whatever star means I'm currently in this master branch. So let me go ahead and get into the BLR branch. At this moment, the number of files that exist in this repository is same. There's absolutely no change in any of the branches. Both master and BLR branch point to the same snapshot. So let me get into the other branch, and the command to do that is git checkout BLR branch. Now I actually switched into Bangalore branch. If you see the content of the files, there's exactly two files the way it was earlier, because I've created a branch from my base branch, which is the master branch, and when I created a branch, there were two files existing here. If you see the content of these files, they would all be the same. All right, so let me create a file that is specific to Bangalore branch. So I would just say notepad. Maybe I want to put down the address of this organization specific to Bangalore in this address.txt. So I say notepad address.txt. I'll say simplilearn Bangalore office. Say located in some address. I would say Bangalore. That is the content of this file. And I'm creating all this new file in this BLR branch. So I would say git add dot, and I would say git commit -m Bangalore branch commit. All right, if you see this, now I have an address.txt which is there only in the Bangalore branch that I'm presently on. Now let me switch back to my master branch. The command to do that is git checkout master branch. If you remember, when I forked out or when I created a new branch from the master branch, I didn't have this address.txt in it. So let me go back to git checkout master branch and keep noticing this particular. What happened to the address.txt? It kind of disappeared. Now, how did that happen? It's all because of this magical git folder. So what happened is, now git knows that when you are in the master branch, the file that was there in the Bangalore branch, which was called the address.txt, didn't exist. So git is playing around with the file system snapshot. So if I come back, let's say I come back to git checkout Bangalore branch. If you see this, the address.txt file appears. So this particular file is only present in the branch, and git is playing around with the file system snapshot by moving the pointers across and ensuring that whenever I'm switching to Bangalore branch, I see this address.txt. When I go back to my master branch, I don't see this Bangalore branch contents, which is the address.txt. All right, now that I created this branch, maybe I may need to push this onto the server. So let me go ahead and create a particular repository structure on the server, similar to whatever we did in our previous exercise. So the name of the folder needs to be exactly this one. So let me copy this and let me create a repository very quickly. I'll go here and say new repository. All right, this is the name of the repository, git branch demo. This is what I'm going to put in as a description. I would say public. I don't want any readme files in it because I already have a repository. I would just say create a repository. All right, let me use the SSH URL. Yeah, this is the SSH URL. This is good for me. So let me copy this URL. Let me add it here. I'm linking my local repository with the server, and let me come back to my master branch. Let me first push my master branch. So I would say git push -u origin master. It asks for my passphrase. All right, I pushed my master branch. It looks good. It says new branch master is created. So if I go back to my server and I do a refresh, if you see, it says only one branch, and it says what is the name of the branch, master. If you see the contents, there is employees.txt and name.txt. Now let's try to push the other branch that is there. The command to do that is a little different compared to the way we created it on the client, because on the client we created the branch with a git branch command. Now this branch doesn't exist on the server, and I need to push this new branch onto the server. So the command would be git push -u origin and the name of the branch that I want to specifically push. All right, now it created a branch out here. Let me do a refresh of this. All right, it says two branches. If I get into this Bangalore branch, I would see the address.txt. If at all I go back into master branch, I would not see this address.txt. Wonderful. Now let me do one thing. Let me try to get the changes from the branch that I created back into the master branch. That is what I would mean by merging. I would want the changes that is there as a part of the Bangalore branch to come back into my master branch. So if I go to git checkout, Bangalore branch, I see this address.txt. This is there only as a part of Bangalore branch. Now, assuming that I'm done with the changes from the Bangalore branch, I want to get those changes back into my master. So let me come back to my master branch. And the way to merge in the changes is git merge. So what is that you want to merge? I want to merge the Bangalore branch changes. And where will it merge? It will merge it into the current branch that I'm on. Presently, I'm in the master branch. So this command would merge the changes from the Bangalore branch into your master branch. So with this, if you'll keep looking here, the content that was there that was added as a part of Bangalore branch, which was nothing but the address.txt, this file should appear as soon as we do a merge. All right, so it happened quickly, and you would see this address.txt that is here. So if you see, let's check the contents in terms of the git log. All right, so there was only one branch that we had earlier, which had only one commit. Right now, we are at this Bangalore branch commit, which was there as a part of the Bangalore branch commit. So with this change, let me push this change onto the server as well. Git push origin master. Okay, those changes were pushed to the server. And now, if at all I do a refresh out here, okay, I'm in two branches. The branches is master. Even if I'm in master branch, I should see this address.txt that is there. Even if I'm in the Bangalore branch, the content is all same because we have merged these two branches. Now that I've merged this branch, I don't need this branch anymore. So I would go ahead and delete this locally as well as push it onto the server so that it gets deleted from the server as well. So delete branch locally. The command is git branch -d and the name of the branch. Only thing you need to ensure is that you should not be currently on that branch which you're trying to delete. So I would say git branch, and I'm presently in the master branch, so I can go ahead and delete the other branch. So git branch -d Bangalore branch. All right, this got rid of our Bangalore branch locally. If at all I do a git branch -v, it shows there's only one branch as of now. However, this branch would still exist on the server because server doesn't know anything about the changes that we have done. We need to specifically push our changes onto the server. Okay, there are two branches still here. So let me go ahead and push these changes so that the branch gets deleted from the server as well. The command to do that is git push origin -delete and the name of the branch. All right, so this went ahead and deleted the branch from the server. Let's check that. Okay, if you see now, there's only one branch. These are the basic steps that you would need to know before you work with any of the branches within Git. And as I said before, the branches are very, very inexpensive in Git. Go ahead and create any number of branches that you want, but just ensure that once you create your branch, finish off your task, and once you finish off your task, go ahead and delete the branch. And before you delete the branch, please ensure that you merge in the branches so that you get in or take in the work that was done as a part of that particular branch. To summarize, the Git branching commands are as follows. To create a new branch, you issue a command git branch, the name of the branch, and this would automatically spin off or create a new branch from the existing branch from where you issue this command. If you are on the master branch and if you execute this command git branch new underscore branch, it creates a new underscore branch from the master branch. Once you create a new branch, in order to get into this branch, you would type in git check out the name of the branch. This would automatically switch the file system snapshot between different branches. Now the branches that are created are by default created on the local repository. In case you want to push any specific branch onto the server, you would have to issue a command git push-u origin and the name of the branch. So this will ensure that the contents of the new branch are pushed onto the server. At any time, if you want to list out all existing branches on your local repositories, the command would be git branch-av. Assuming that you did all your work in a new branch and you're happy with the changes, you would want to bring back those changes into the master branch. The command to merge the contents of any new branch into a master branch would be git merge and the name of the branch. And this would automatically merge the branch contents that you specified into the branch on which you currently reside. If at all you're on the master branch and if you issue a command git merge new underscore branch, this would merge the contents of the new branch onto the master branch. So once you merge the contents of any branch, you would possibly want to go ahead and delete this branch. So the command to delete those branch locally is git branch -D and the name of the branch. This again would delete the branch locally. In order to make this change on the server, which is in order to remove this branch from the server, the command to do that is git push origin -delete and the name of the branch. This would also delete the branch that you created on the server.
In this session, we're going to cover the topic of what is Angular. I'm sure all of you use mobile and web applications. Be it from social media to healthcare, e-commerce, and net banking, these apps are used